it's not going to be synthesis.
What?
It's not synthesis, right?
The first one isn't?
No, you said the second one.
Yeah, it's not synthesis.
It's not synthesis.
And is it single replacement?
Ah, bingo.
Double replacement, right?
Yeah. Did you say that test on? No.
Going over the homework from last night. Checking the homework last night. So you'll see those again on the quiz Friday. Okay, very good. So the question is 10 points. What do decompositions always have in the reactant? Always has in the reactant what?
Two compounds.
One substance. So it says right here, notice that this decomposition reaction involves one reactant breaking down into more than one product. So decomposition typically involves one reactant breaking down into one. That's what you kind of look for. When you're looking at these, you're like, what type of reaction is this? What's it going to produce? More than one product. All right, so moving on to replacement, that would be single replacement reaction. We talked about this Monday. Who wants to read there? Let's go with the first paragraph. All right, Adam.
In contrast to synthesis, combustion, and decomposition reactions, many chemical reactions are replacement reactions and involve the replacement of an element. These reactions are also called displacement reactions. They are two types of replacement reactions: single replacement reactions and double replacement reactions.
All right, so with the single replacement reactions, we learned on Monday about the activity series of metals. And lithium, is lithium more active or less active than gold? Yeah, lithium is more active. What does that mean, it's more active? It's going to require less energy to get its electron away. So we talked previously in the chapters about page 192 in the book. This is a review of the ionization energies. And if you see that lithium requires 520 kilojoules compared to, let's say, I don't know, boron or beryllium. They don't have silver on here or gold like they had on the activity series. But you can see that lithium still requires energy to react. It's just less. Substances just don't react on their own. There has to be some type of initiation. Does that make sense? Okay, so lithium, it's kind of reactive because it doesn't take a lot to get it like upset. And you'll see this in life. When you go to the workplace, you'll see some people are, it takes a lot to get them upset. And other people, just one little thing, and they're flipping out, throwing books, papers, everything is going crazy. They're like, that person's definitely like lithium. Non-metal replaces a metal. Non-metal replaces non-metal. So let's read that there. Third type of single replacement. Who wants to read there? Third type. Page 294. Non-metal replaces non-metal. All right, go ahead.
Third type of single replacement reaction involves the replacement of a non-metal and a compound by another metal. Halogens are frequently involved in these types of reactions. Like metals, halogens and typically single replacement reactions. The reactivities of halogens determined by
So it's important to notice the pattern here for the electronegativities. Fluorine has the greatest, and the direction is going across a period and down a group. Does everybody see that? That's how the values, so it increases across a period and it decreases down a group. So when you get your periodic table, electronegativity is going to tell you which one is stronger. So fluorine she's going to replace. If fluorine is already with a metal, that is, you have a compound, it's not going to be replaced by something else. It's like you're tough. If you look at the example in the book, fluorine plus sodium bromide yields sodium fluoride and bromine, or bromide. So that would be, yeah, bromide. Oxide is O2 as well. So this is diatomic Br. Now this is not a reverse reaction is what I'm trying to explain to you. If you had Br2 plus NaF, there would be no reaction. It would not react because the fluorine is stronger. Does everybody understand? So we have some cartoons here today, and it would be kind of similar to, let's say that Bill Gates and Melinda Gates, right? That would be your example of sodium fluoride. Bill and Melinda Gates, let's say Bill is sodium and Melinda Gates is fluoride. Somebody, some other female, most likely she's not even strong enough to replace Melinda. She's just too intelligent, right? So, many women are extremely intelligent, and those are the ones that see what's going on around them and are not going to let things like that happen. They're going to make sure that they protect themselves, right? So this would not occur, this reaction going backwards would not occur because the fluorine is just too strong, too strong of a desire. Not going to overpower her. All double replacement reactions produce either blank, blank, or a blank. So this is kind of like a little pre-quiz. Does anybody know the answer?
Oh, wait, hold on. All double replacement reactions.
One. Or a 3.
Is this the other thing we just read?
No.
Oh.
All double replacement reactions produce either water, precipitate, or gas.
Very good, Michaela. So this is really the key point that Michaela just helped us with. Double replacement reactions, this is what they're going to produce. So we had our 2 points with single replacement reactions. Double replacement reactions, you're going to look for this. So if you see water, you see a precipitate, or you see a gas, you know it's going to be double. So let's read a little bit here. Double replacement reactions on page 296. Who wants to read that for us? All right, go ahead, Adam. If you choose two substances as a reactant and you mix them and they're both aqueous in the product, that's not a double replacement reaction. It's just equilibrium. It's like the ocean, right? In the ocean water, salt water, you have Epsom salt. Very difficult to get the Epsom salt out of the seawater because it's aqueous. So it's just not profitable. Chemistry is really a science about profit, making money. Like if you get a chemistry degree, you think, okay, where am I going to use this? Then you go to, let's say, Ford, or you go to a food company where they have artificial esters like wintergreen, or what's another flavor you like? Spearmint, or cinnamon. Right. So you work on ingredients that are going to make your customer happy. Cody, nice job on that, balancing that. Let's do one.
Is this the same one you put up yesterday?
Yes, very good.
Oh, yeah, because
Yes,
that's
yes.
for...
Oh, you actually made that? Yeah. I don't get it. Oh, it's so cute.
It's a Russian
That's confusing. Well, our visual representation is all...
Balance double replacement reactions, trying to balance those. I always start with the polyatomic ions. You see there are 3 here, and you see you have 1 over here. So I'm going to put a 3 right here because I need 3 of these. I only have 1. See, there's 3, right? Yeah. So then I look. Okay, I see I have 3 OHs here, right? And I need 3 over here, so I'm going to put a 3 here. So I can see now that my polyatomic ions are balanced, right? So now let's just see, is everything else balanced? So I got 2 ALs here, right? Now, initially, we had 1. So that would be a problem, right? So you're like, okay, the ALs are not balanced, so I'm gonna have to double that. Now when I did that, I now have 6 OHs, right? So I have to come back and change this to 6. Everybody see that? Why I did that?
2 times 3 is 6.
Because I put the 2 here. Originally it was a 1, right?
Right.
Originally it was a 1. You had a 1 there. But my aluminums were not balanced.
So you have to.
So I had to put the 2 there.
And then you have to do 2 times 3 to balance.
Right. So that came that to 6. So it should be, we got a 6 here, that's good, and you got a 6 there. So it looks like we are balanced now. Yeah, so once again, start with your polyatomic ion.
This whole time she been letting me call her Gilly.
I like Homer there with the pig.
I want like something.
That could be like in his oven, baking
His
the
oven.
brain. What's that piece of cheese?
It's like a gem. It's from a game.
That's cool. These are correct. Nice job, Kara. A couple of these will be on your quiz on Friday, so you might want to write those down. The bell.
Hydrogen atoms in the water molecule. A reaction in which atoms of one element replace the atoms of another element in the compound is called a single replacement reaction.
Series you see on 293. And what is the activity series based on? Anybody remember? Ionization energy. If you go back, you can check chapter 4. If you look at the ionization energy for lithium, it's like 600. Very low amount of ionization energy needed. It's like 520 kilojoules compared to gold, which is going to require a lot to get an electron away. You're going to have to smack gold quite a bit to get an electron. Let's hold on to it. So if you are in a comparison like your cartoon right here, let's say the person with the dark shirt on, let's say that person is a NBA basketball player, and the person dancing with the girl is, let's say, a high school dropout, right? Who's going to be the better provider? The NBA basketball player. Now, I mean, it's all, when you start looking at the needs of life, there are needs in life, right? We just have to be honest. If you go out there and you're like, you're living, bills have to be paid, rent has to be paid, utilities have to be paid, a mortgage has to be paid. And if you're a high school dropout and you're having a hard time, getting a job, guess what you're not going to be able to do? Vance? You're not going to be able to be a good provider. So the NBA basketball player, he's worked hard, or she's worked hard. They're both men and women in the NBA. So keep that in mind, that the provider, that is lithium here, has it takes very little for it to lose that electron. Now in the workplace too, you'll go places and you'll probably work in the future. Some people, they freak out with just a little bit of input. Like you give them a little bit more work and they just flip out, start throwing things and cussing. Oh, I'm not going to do that. Blah 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 blah. And there are other people that are just like, yeah, I'll be happy to help you with that, no problem. So the people that freak out really easily, they're like lithium. So remember that. There are lithiums out there. You just, you barely say anything to them and they just, and then you have gold, right? So gold would be like, who in here is like gold? Say, Diana, you kind of like gold. Gabrielle, gold. Lily, you silver. If you go to UPS and they catch you dating a fellow colleague there, they will fire you because of the problems associated with, you know, relationships like this. One person separating, and then when separations happen, especially if they're in the workplace, it can cause profits to be decreased or less.
They represent positively charged ions, cations, and mixed environment.
So double replacement reactions always produce three things: water, a solid, or a gas. So those are the things we're going to look for when we see a double replacement reaction. Very good. Jaden. Can you get the top one here? It's a tough one. That's the hard one.